This video is a continuation of the previous video about two-way tables. We're going to focus on some percentages, a little bit more with 3 percentage examples. A quick note before I get into these examples, I like to think about a percentage as being equal to the characteristic I'm looking at, or the variable I'm looking at, divided by the total of whatever I'm looking at. Right, so you can think about a percentage as the characteristic divided by the total, and for now we want to use these percentages compared groups. We don't want to use raw data, but percentages. Example 1 says we've got a stats class. It's made up of 15 men and 23 women. I want to know what percentage of the class is male. So I'm looking for the percentage in this formula. So the percentage I'm looking for is equal to the characteristic I'm looking at. In this case, it's being male divided by the total. Well, I know there are 15 men in the class, so 15 males. Over the total, be careful here, it's not 23, but the total is 38. If you add the 15 men and 23 women, that gives you a total of 38. So I'll find my percentage by taking 15 dividing by 38. If we round this to 1 decimal place, after it's a percentage, it would be 39.5%. The 7 rounds the 4 up to a 5. In example 2, we have a different class that's much larger. There are 234 students, so that's my total, and 64.1% of them are men. I want to know how many men are in this class. So again, I use this form. The percentage is equal to the characteristic divided by the total. So I have the percentage at 64.1%. It's equal to x over 234. I don't know how many men are in the class. I don't know how many people in the class meet that characteristic, that criteria, but I do know there are 234 people total. I want to solve this for x. In order to do that, to get x by itself, I'm going to use a little bit of algebra. I'm going to multiply both sides by 234. The left-hand side and the right-hand side. So these 234's cancel out. All I have to do is say 234 times 64.1%. On my calculator, 234. There is not a convenient percentage key on the TI-83 or TI-84. I'm going to convert this 64.1% to a decimal. It would be 0.641. Just move that decimal 2 places to the left. I get 149.994. This is supposed to be the number of men in a class. I can't have 149.994 men. It makes the most sense to say, well, that just rounds to be x is 150 men as my answer here. In example 1, we were missing the percentage. We found that. Example 2, we're missing the characteristic, the number of men. Example 3, we're going to be missing the total. It says a different class, not a class from example 1 or example 2, is made up of 40% women, and it has 20 women in it. I want to know what is the total number of students in this class. So I have my percentage, it's 40%. It's equal to the characteristic of 20 women over the total is what I want to find here. Well, there are several ways to go about solving this problem. To me, it makes the most sense to rewrite it in a slightly different way. I'm going to rewrite 40% as 40 out of 100. You can rewrite any percentages, that number over 100, and keep this as 20 over x. If I write it this way, all I have to do is cross multiply the 40 times the x and the 100 times the 20 to get rid of my fractions. If I do this, I'm going to get my new equation to be 40x equals 2,000. And now to solve for x, just divide both sides by 40. So on my calculator, I'll take 2,000 divided by 40, and that gives me x must equal to 50 total people in this class. So these are 3 ways we can look at percentages in Chapter 1.